Hello everyone, my name is Dr. O'Connor, and so I've got two immediate problems with Dublin and saying that. One is that I have an English accent, and despite the fact that I've got that name and I work in London, I'm not Irish. And the other problem is that I mispronounced my own name. So just putting that aside, it's really nice to come over here and have the chance to talk to you about what we've been doing in microservices for the last 2 years. I wish we had got as far as Boyan has with his team at Halo. I think our challenges are different because I work in a large enterprise company with a significant legacy IT estate. So my talk will touch on how we've dealt with those problems. So, running back, I work at ITV, which is short for International Television. We've been around for about 50 years, I think. We are, hang on, this is the way my boss says it, we are Britain's largest commercial television broadcaster, which is a very fancy way of saying we're not the BBC. We started out just broadcasting on a single channel. Now there's Sky, cable, digital, and lots of different ways of catching up and watching the television show. I work in the online department, so that's where I've been building websites and applications to support. A lot like iPlayer or perhaps Netflix or something that you're more familiar with here. I've been there for 2 years, and when I joined ITV, they said you'll be building microservices. And that was an interesting moment for me because I was like, yeah, okay. Because 2 years ago there wasn't anything really on the internet you could find out about microservices. That's all changed in the last 2 years. It's been amazing, especially the last year. We've had 2 conferences, 2 major tracks and 2 big conferences just dedicated to microservices. And it's been really exciting to see a lot of the things that we've done validated by other people talking about best practices there. And I'm sure it's been much the same experience for the Halo team as well. One thing that I didn't see anyone talk about so much, and what I'm going to be talking about tonight, is how you put microservices together, or aggregate, as I put in the title. And we've had to do that, and I think most people do, but it's something that people rush over in their rush to get talked about the basics and some of the other parts of microservices. So that's why I developed this talk, and that's what I'm going to concentrate with you on today. Like any good television show that ITV makes, tonight's talk is based on a true story. Specifically one project that I worked on at ITV over the last 2 years, and also like any good TV show, or at least any good ITV TV show, I've had to bend the truth a little bit, outright lie in places. If it seems at the end like things went swimmingly for us, that's because I've papered over the yawning chasms of the problems that we face to generate a nice narrative. So we've got 4 parts to the talk. We'll start by just framing where I feel about microservices, and also where ITV was as a company when we started out, to really sort of ground us and get us a sense of what we're talking about as we progress. I'll then talk about the basic building blocks that we had to develop for our team, for our project, and how we approach putting it together, how we developed that approach, made mistakes, and learned from those mistakes. So it'll be a journey as we go on. And at the end, hopefully this time, we can talk a little bit about versioning our APIs as well. So that's something that fell out quite nicely from what we learned about aggregating our APIs along the way. So, I love this quote by James Lewis. How you build microservice. You stand on the shoulders of giants. Every time I think about microservices, I'm very mindful of that, because microservices are a real challenge to get right. There's so much you need to know about it. But, this is a really positive way of thinking about microservices, and that's because James Lewis is a consultant, so he's a very positive kind of character who's selling microservices to his clients. In reality, microservices are a bit more like an iceberg. Here's the canonical book on the subject, written by Dan Newman, which is fantastic, and I recommend everyone reads it. And sort of introduces you to the topic. And here's all the other books that we feel you need to have read, know about, and be aware of if you're going to actually listen to a talk on microservices, or if I'm going to present a talk on microservices, I need to know this stuff. Or if we're going to work together in a team, I think you need to know these things. These are so much wonderful sort of books that have come out over the last 10, 15 years that have really sort of enabled us to get to where we are. You can really think about this as also as the foundations for microservices architecture. The problem with anyone talking about microservices is that you've got to navigate this massive collection of knowledge that's built up over the last few years. And it's really hard to do that in a talk in 45 minutes. So you've got a really hard choice: either sort of spread yourself thin and try and talk about everything, or which is what I'm going to try and do, is go very narrow and very deep. So we'll be focusing today on I'm a developer, on the development choices, the architectural choices, the design patterns that we took for composing microservices. And we will be skipping over all of the things that we learned along the way around testing microservices, how we're testing aggregation microservices, deployment, team organization, things like that. All of which are really interesting topics that deserve a talk in their own right. This is the application that we built. It's a catch-up television application on a smart television. So if you bought a Samsung television in the last 2 years, if you lived in the UK, it will come pre-installed with this application that allows you to watch your favourite TV show that was shown in the last 30 days. And yeah, it's pretty standard for all the different platforms that we've got. We've got similar applications on as a website using a computer, and also the iPhone and Android. We even already had an application that did something broadly similar on smart TVs. And so when we started out, the first thing we said was, well, why are we building a replacement? What's going on at ITV that means you need us to build a new version of this application? Yes, a nicer version, but not just the client. You want us to replace the server as well. You want us to change the APIs. What's going on here? So we needed to dig a little deeper into what ITV was going through and why these changes were necessary. I want to share those with you. We started by talking to the IT managers responsible for the existing services that all of the different clients for television catch-up talked to at ITV. And what they told us was that it's difficult to understand our current IT infrastructure in our department. It's even harder to change the code that we've got. And we've reached a point where we actually feel we need to replace this system. And I think a lot of us have been in this situation. Anyone who's in the microservices space is there because they're familiar with at least one monolith application. So Boya talked about going through a similar experience at a startup. This is a monolith that's been around for, say, 10 years and accumulating lots more features over a significantly longer period. So that's a reasonable argument. We also needed to think about some of the other IT systems that are there at ITV, because it's not just the system that you need for catch-up television. You need to rely on core parts of ITV in order to provide shows that you can watch. So we talked to those managers, and they told us that we've got these core systems that are also very difficult to change, even older. And what's worse, they don't scale, so you can't access these things with millions of people at the same time. And yet we're not ready to replace them at all. So we're in this difficult place where we can replace some parts of the IT infrastructure, but not others. Finally, we had an architect on the team, but he was my favourite type of architect, what I like to call an evolutionary architect. And he helped us by talking to these people with us and thinking about the problems and framing and providing a vision for what we should be developing. And what he told us, based on that conversation, all those conversations, was I need you to isolate and protect the core systems because we can't replace them yet. I want you to build microservices because we want to avoid having that monolith. And I want you to use REST as your standard integration path for doing that. So there's lots of different ways to integrate microservices. And REST is one that's very simple to understand. It's not necessarily the best. But it was something that they were confident we'd be able to spread to other teams as we got further. So that's where we started. And with that in mind, we went out and we thought about what are the basic microservices that we need to build at our TV or this video-on-demand catch-up application. And what we needed to build were what I like to call domain services, which is really just the basic pieces of business functionality that you can look at and work on in isolation. And in order to find those, we had to start by thinking, well, what are the basic things that we're trying to do in our application, and if we work back from that, maybe we can identify the main services that we need to provide that functionality. So we took a screenshot from our application that we'll be developing, and we looked at this and we said, well, this is the go-to page for most people watching some television content. What are the things we need to do? What are the services we need to provide to make this screen work? So we started pulling out pieces of data. We saw there's basic catalog data. We can see that we've got everything has a program title, a series number, an episode number, and a synopsis. We can group that together. We can call that a catalog. We can even go and find a team, as it happens, that's responsible for managing that data in an IT system that our department wasn't really aware of before. We can see other bits of data that group naturally together. We've got schedule data, what channel something was shown on and when. Now, as it happens, the product catalog data is copied into the schedule database. But there's only one source, one true source for each of these pieces, each of these groups of data, and that's what we were really looking for all the way through. Canonical source for data and the teams that manage that data. There's other data we had, the licensing data. Interestingly, if you're going to watch something, which platforms is it available on? Is it available on Android and iOS as well as on the website? That data was managed in the same database as the catalog data, even though there were two separate teams managing it. Okay, but for us, that's two separate domain services, even if it was one database. We've got images, and they sit in their own asset management system, and there's a team dedicated to managing those images, so we can deal with them separately. Ditto guidance, which is whether this show has bad language or not. There's a separate database that stores that information. And finally, the video asset itself, which will be built especially for whatever platform that you're watching this piece of content on. So we've got all these different domains that we've identified, and I don't think that's too unusual, even in a non-microservices team. This is really just applying principles of domain-driven design. What's interesting for us is that instead of trying to model these domains within one system, we're saying that each one of these domains deserves to be pulled out into its own microservice, or its own service, or series of microservices. So it allows us to categorize the data and group it, and so that. Then what we end up with what I like to call a set of bounded contexts. And what's going on here is that there's, in our overall microservices architecture, there's going to be some data that's common across everything. In our case, it's mostly episode identifier for whatever show we're watching. It's universal, it's a UID, it's not going to change. And there's going to be other data that's private per microservice, per domain. So unavailable outside of that bounded context. And that could be, in the case of, say, the guidance domain, something like an audit trail of who approved or disapproved certain guidance information, maybe even expiring information, things like that. And then there's other data that needs to be shared between the bounded contexts. And that's the integration points, it's the APIs that these services use to pass data around. And what we want to do is make sure that we've got the cleanest and best possible APIs for these services talking to each other. If we've got that, what we can hope to get is a high cohesion and a loose coupling, so that when you make a change in any one of these domain services, you should hope that that change won't ripple out to other services. And also that it's going to be, if you do make a change that does affect other services, it's in a limited fashion. And we can also hope to get that when you're talking to these teams that manage these individual services, if the code matches the team, then you're going to have conversations about the design within one team, and you're going to have a much better, clearer conversation with that team about how that service should work. So it was really key for us to make sure that we got these boundaries defined correctly. And it looks quite simple now that I'm presenting it, but it was a lot more convoluted as we were discovering how our systems work, because the system that we were replacing just put everything together and created this giant spaghetti. We also wanted to think in a resource-oriented fashion. We're developing a REST architecture, and we're exposing resources over HTTP. But even more importantly than that, we wanted to make sure that things were well named, and that we were using a ubiquitous language that the business was comfortable talking to us in, so that our code actually matched the way that the business worked as often as possible. For today's talk, we'll concentrate on just 3 of the domains: catalog, licensing, and guidance, because that's enough to give you a flavour of what happens when you start composing this together. But all of these services would be communicating in much the same way for the rest of the talk. And just to quickly give you an idea of how our REST APIs might look, so that we've got a common ground. Here's a catalog, stripped down catalog endpoint with a fairly simple URI. We've got an episode identifier on the end, and some basic information that we would need on that screen that I showed you earlier from our application. Here's a guidance API, it's probably similar. Notice that it's got the same episode identifier, it's got different information that it exposes. Licensing is slightly different because it will return a list of licenses, so it's a query on an episode ID of the licenses themselves, so individual resources will get out. So you can see that we're very much focusing on the episode ID all the way through this talk. I want to talk quickly about how we actually built the domain microservices. And what we've got here is the legacy system that we were wrapping, and we couldn't get rid of a microservice in front of those legacy systems. And it's useful to think about these microservices at this point as an anti-corruption layer, if you like, or a proxy for these legacy systems that we know we can't replace. Such that when we do replace these legacy systems, there's only one place that we need to update to actually to actually spread that change out, and that also means that we can keep, hopefully, the same REST API that you'll see. In front of each microservice, we put a cache. It's not too important that it's varnish. It was useful to have an HTTP cache, and it was really useful to have a cache with really configurable and allowed you to do powerful invalidation, as we'll see in a second. Because what happens when a request comes in for some data is that it goes through to the microservice, which translates it and does whatever necessary call on the back end is required, and it gets cached and put into varnish. And that means that when another request comes in, it's usually just going to hit the varnish cache. But the way we wanted to use the cache was that if there's any change to that data, we get that straight away. We don't want a 30-second cache, which is how you might traditionally have in Varnish or any other HTTP cache set up. We wanted to cache for a month, but until the data changed, essentially. So what we made sure was that every legacy system that we integrated with, as well as providing a query mechanism, also allowed us to find out when data had changed, and that was vital. That could just be as simple as an audit table that we could introspect into. Some services actually send us messages over a bus or something like that. So that when we get an update that something's changed, we can use that update to invalidate our cache for that particular change, and then confirm that update as consumed in our database. That's important because if our microservice were to crash halfway through invalidating that cache, we guaranteed to make sure we replay that update and re-validate the cache. So we will always make sure that cache gets updated as soon as possible. It's not perfectly consistent, but it's as close as you like to get. And then when another request comes in, it's going to bypass the cache in most cases and refresh it with extra data. So that's the basic model that we work with all of our domain services. We then needed to take those domain services that we've got and put them together and build the actual screen, the APIs that we could use to power the application that we were building. And to do that, this is a really useful screenshot from a blog post by Netflix, which describes what I think most people, even in the Netflix blog, can end up doing, and what's called the API Gateway Map. And Netflix have, in some ways, similar service to us. At the top, you can see lots of different applications. So
each one of those can have a different mechanism for communicating with Netflix's servers. And so Netflix provide a single gateway that can communicate in any of those transport mechanisms, be it REST, be it sort of binary WebSockets or something, and translate that to the internal API format that they use at Netflix, so that from then on, everything is consistent. As well as that, what the Netflix gateway patent tells you to do is if you can have one single request coming in, you can then make lots of requests out to all your individual microservices, fanning out essentially, and then wait for those to come back, orchestrate a response, and send it back. So you've got a really simple integration point for your clients, and you're hiding the complexity of all your microservices underneath. And that's essentially what we started out with. And the talk today is a lot about how that became a bit of a problem for us, because looking at this gateway pattern, what we started to see as we put more business logic into making sure that we orchestrated over the right APIs correctly to generate the response was an awful lot of complexity being compressed into this gateway. And almost like this monolith microservice, this microservice was turning into a monolith in front of all our individual domain services. And this was starting to become a challenge for us very quickly. And so what we're talking about today is how we looked at that problem and tried to think about taking a step forward from there. I want to briefly say that some vendors have already come up with solutions, which is scary in itself. If you're familiar with service-oriented architecture, which was really, everyone would say, the basis for where microservices came from, developed in the 1990s. It wasn't really until maybe the late 90s, early 2000s, when vendors came in and proposed solutions for building your SOA architecture, ESBs. I like to think of some of the really sexy startups for API building that we're seeing come out at the moment as the potential ESPs of tomorrow, because at least it keeps us on our toes. So an example of one of these might be Apogee, who provide a security gateway for talking to REST APIs, but they also provide an ability to mash up your APIs. And not to pick on one vendor in particular, CA also provide a customizable API composition tool. They used to be level 7. So we've got all these vendors providing ways to mash up your APIs together and help you put all of your complexity into a configuration file on their servers, which is great. But what they're really doing is taking a difficult problem and making it easy for you. And when I see that, I remember this talk by Rich Hickey, which is one of my favorites, where he talks about simple versus easy. Because when you buy a vendor solution and you make a problem easy, you're losing the opportunity to think about that difficult problem and try and break it down into a series of more simple problems, and so spread the complexity out. So you're sacrificing long-term performance for getting something quick out the door. So what we were thinking when we were dealing with this gateway and the complexity it was causing for us was how can we find a solution for us quicker than we can end up having to use a vendor solution to get us out of this problem. And so we set out to do that. But we'd still done a lot that was really good, so we should stop for a second and review. We defined some boundaries, which is fantastic, even if we got nothing else out of adopting microservices. So much of what we were doing was now in these little domain services that compartmentalize the complexity of talking to create systems. We'd started to think in a resource-oriented fashion that actually matched those boundary contexts, which is fantastic. And we put anti-corruption layers around our legacy systems so that they could be replaced and we could manage that process effectively. We compromised, we'd ignored those underlying data stores. There are teams out there now thinking about how to replace them. We'd made it not our problem, which isn't ideal. And we'd acknowledged that the API gateway is in danger very quickly of becoming a monolith for us. So, we went about solving it and we did it the wrong way. But we learned from that, and so there's a chance that by doing this talk tonight and making a fool of myself, you can all learn from that as well. what we did was we looked at our API gateway. So there's the ball of spaghetti that I was talking and some clients that talk to it via it to various domain services in the background. And we took a step back and we thought, well, what is it we're trying to do? We could, one way we could solve this is we're doing thousands of requests for some of our most complex queries. We could come up with a batch mechanism for transport. So we work with APIs off the internet, which allow you to batch together lots of queries, and that would be one way of managing complexity. We actually didn't do that because we liked the REST architecture that we got, we liked the caching mechanisms that we've got, and we were looking for other ways to manage the complexity. So we started to think, well, what we're really doing is we're kind of using HTTP to simulate what we used to do in a database for some parts of the application we were developing. We're essentially doing what we used to call an inner join on our SQL, lots of different tables, each table is a microservice. But we're doing it over HTTP instead, which isn't ideal. But maybe we can leverage that. Maybe we can actually put this data into a database so that we can do that sort of join query. That would be a lot simpler than thousands of HTTP requests. So we tried it out. This is what we got. We called it the Video On Demand Aggregation Service. And if that sounds like a smelly name, it will turn out to be one later on, so hold your hats. It's straight away, we got some benefits out of it. You can see that we now could have tiny little API gateways, one for each of our platforms. Because all they had to do now was worry about the translation from whatever protocol the client used to, and then make a query into the aggregation service. So that was good. Separate microservices there, reduced the code base. It had its own data store, which meant that it could no longer query out to the domain services, which meant they had to tell it what the data was. So the arrows that previously went down now go up. That meant less HTTP calls, because what we were previously doing with thousands of HTTP calls, we could now do with one single query, which was great. We could exploit the appropriate data store for the problem space, which is really powerful. Essentially for us, that meant we had lots of different types of data that we weren't too worried about how you put it together, which screams document store, denormalized data. You can use Mongo, we used Elasticsearch. And it's great to have a different way of processing the same data, use a different data store that's got powerful tools that are powerful in a different way to what you need when you're, say, working SQL and need transactions and that sort of thing. And yes, like I said, we were populated by events. And to do the population by events, we had to modify the existing domain service architecture that we already developed. But actually, it worked out very well, because we only just had to extend it a little bit. We were getting these update events when things changed, and we were using those to invalidate our caches. But now, instead of just confirming that, we also just sent a message to our queue to say, hello everyone, there's been a change in the underlying data store for this. You should know about it. And only once that's done do we actually confirm that update is processed in the data store, which again means that if anything goes wrong, we can just replay that. So we've expanded the transactional boundary, essentially, for these updates. You can rely on that message bus to tell you whenever there's any change, and that's powerful. And that's an API integration for that. And then we use that message bus. We use those messages. We take them off in our aggregation service. And at this point, I should actually say what these messages are, because they're not the data that domain service stores for that episode, and they're not even a delta of that data. What's changed? What they are is just the identifier for that domain. So it will say something like license and episode ID 123456. Nothing else. And the reason we have to do that is because we're using, as it happens, RabbitMQ, but we could be using SQL, so it doesn't matter. Nearly all of the messaging systems that you're going to be working with offer something called at least once guarantee of delivery, and which is really weird when you first see it, because you're thinking, hey, I just want to send a message and get it at the other end. What do you mean at least once? But it's actually makes a lot of sense once you actually start thinking about failure modes that your system's going to operate in. Because if we go back to the previous service, we've already said that this could crash, and that could mean the message gets reset. So that's already one way in which a message gets sent twice. You need to be able to handle the fact that your messages could be multiple times, and also out of order, because once you've crashed, you can replay things in any order. And it's really important to be able to deal with that. And to do that, we use what's called the idempotent message receiver pattern, which just essentially means that because we're only sending the ID, we don't care what order you send the ID in. We can handle it, and we can deal with that after the fact. And we do that by, as soon as we get that ID, we go back to the domain service and we say, okay, now we want the data. Now give us the data you've got in that domain service. And from that point forward, we do make sure that all the data is properly ordered and that we send these messages at least once within the bounded context of this service. And we can do that because it's just one service, it's not a distributed system. And so we've got these now ordered data, which we then store in our aggregation store. And then we confirm back to the queue that we've processed that message. And again, if anything crashes, we've got a transactional boundary at work here, and we can replay that identifier and guarantee to get the correct data into the aggregation data store, even if it's changed, because we're only replaying the ID, we're not replaying the data. Which is fantastic. We've got a method of populating our aggregation service. But to stop briefly and think about what these different types of services are, because we now have got into a situation where we've got this domain service, which is one way of looking at some data, and the aggregation service, which works slightly differently. So to review, the domain service often feels to us like a single database table, if you're lucky, and you can build a microservice that small. You only need one table. Whereas an aggregation service is more like what we used to have with a projected view of a number of different tables. You remember maybe you developed an application 10 years ago where somebody wrote a trigger where every time you inserted some data into one table, that would copy that data across to a denormalized view of that data that was needed by some other application. And what's interesting about doing that, even in databases, is that when you work in a single table, you can say that data is consistent. You can say that you've always got the right information. But as soon as you start compiling this data from different sources and relying on the data being in one place before you copy it to another place, you're sacrificing that consistency. You acknowledge the fact that if it tracks slightly behind, it's eventually consistent. So when we were developing this aggregation service, we were talking to the business and we were saying, hey guys, it's going to be about 500 milliseconds behind the original source. Is that okay? No. Yeah, that's it. But it matters for us perhaps more than that. When these domain services have changes, those changes are being made by people. There are people logging in and updating the schedule information and things like that. Whereas our aggregation service is entirely populated by these events that are being generated by those domain services. And no human should actually be able to log in and make changes at all. And it's been very important for us all the way through to ensure that. That also means that we need to be very careful about backing up the data that we've got in our local data store, but that we can afford to throw away at any time the data in this aggregation service data store. And as long as we can replay the events from our domain service, we can recreate it from scratch. Which starts to get close to something that you may have heard of called event sourcing, where you model your systems less around the sort of mutable state of your data, and more around the process of events over time producing state. Which is extremely powerful, and we're exploring that space more. I think we'd like to have a purely event-driven architecture and event sourcing architecture. This is the aggregated resource model. So we've got our different domains that we talked about earlier, and it's where we start to see things actually go wrong, because you need to put those together. And this is the VOD aggregation service that sits in front, and it's got a nice query URL for getting information. That makes a lot of sense. I want to know what episodes of Downton, things beginning with Downton are on channel, and please give them to me in alphabetical order. That's fine. Even actually what we respond is good for developers to work with, because we basically just returned a denormalized dump of our data store with all of the different domain services just mapped as sub-JSON objects, essentially. The problem was, as soon as we actually wanted to make changes to our services architecture, as soon as we wanted to update a field or even just add a field to any one of these domain services, we immediately had to make the same change in our blog aggregation service. Essentially, we've got a distributed model on that. We've got really high coupling between this aggregation service and every domain service that the data is with, which is one of the problems that I talked about at the beginning, I was trying to avoid with our domain services, but we've introduced it on steroids into our aggregation plan. And essentially, whatever the other benefits, this made this unworkable for us. It's just not sustainable to operate like this. Nevertheless, I think we've taken some step forward by doing this, and it was an important step in our journey. Because to start with, we reduced the code size quite significantly. We could separate things out as separate microservices, so we've got those separate API gateways, which were much easier to integrate with our aggregation service. We eliminated all of those inner HTTP joins that were a bit of a nightmare to orchestrate, and we replaced them with a single query that was 5 lines essentially, and that's it. And that was a lot of the logic in one place at that point. And we put all of that logic into a specialist data store, which was well suited for the problem we've got. As we've said, we've got this huge coupling problem between our aggregator and our domain services, which we couldn't live with. And we need to update our aggregator if the domain services change. And so we had to set out to fix that. And what we did, in order to fix this, was take a step back. Go back to the basics. In fact, go back to this screen here, and say to ourselves, what are we missing? What are we doing wrong? How did we get into this situation where essentially we've got this microservice that's just coupled to every other microservice? Maybe if we just model things better, we can actually dig ourselves out of this hole. And as we stared at this and talked about it, what we actually started to see was there was something else going on here that we didn't immediately leap out of us, because really this screen should only appear at all if certain criteria are met. And previously, we just put all of that logic into our API gateway and our aggregation layer, where we're saying, like, does something have the requisite catalog information? Was it scheduled? Is it licensed for your platform? Is the video asset ready? Has the guidance team signed off? There's a lot of logic going on there to determine whether this episode meets the criteria that makes it viewable. And just left out of us, say, okay, there's a concept here, there's a domain, and it's called availability. Even better than that, you can see right on the screen, I don't know why we didn't see it straight away, you've got some text at the bottom. 5 more episodes, which is text that only needs to be provided by a specialist availability domain API. Because we don't need to know for these 5 more episodes if they've got what the synopsis information is, what images they have. We just need to know that there are 5 more episodes of this series available. And with that in mind, we can start to rethink about how we do aggregation. We start thinking, well, instead of just having all the data exposed at this aggregation layer, maybe we can just model the availability portions of what we're doing. And so that's what we did. We still needed all of the data into our availability service. We couldn't get away from that because we need to make a decision about whether something's available. We still need that powerful query API. We still need to be able to say what is available on the channel ITB that we can input down to. But we can be much more specific about what we return. We need to return the episode ID, but that's okay because that will never change. That's going to stay the same. So no one's going to be updating that in any of our APIs. And the only other thing we need to return is whether or not the episode is available or not. But everything else, you can go to the source. You can request the catalog information. Better than that, we can link you to the catalog information. And in some cases, let's say guidance, if there's guidance text, we'll link you to the guidance text. If there's not guidance text, we won't bother. So we can do an awful lot just by providing links to the right services instead of providing the data itself. Even though we've got the data, we don't share it. And this reduces, it doesn't eliminate, but it massively reduces the coupling. Because now when we change a field in our catalog service, it will probably end up in the data store for our availability service. It may or may not be a factor in how we decide on whether something's available or not. But it's not going to be something that we necessarily need to change the API for. We may need to update the availability service even, because it may change the concept of availability, but it's very unlikely to update the API, because that's just returning true or false. And that was hugely powerful for us. But it also helped us in other ways, because we've been building, actually, in retrospect, very immature REST APIs. What's often called level 1 or 2 in the Richardson maturity model. So we were returning basic resources and potentially using the right verbs. But we weren't really thinking about how these APIs work together. At this point, we're now actually starting to reach level 3, full patios, which is hypertext as the engine of application state, where someone who's using this API knows what state that they are in just by knowing what links they can go to. They can navigate around your APIs just by going to one resource with a particular query configuration. And much better for people to work with at that point. You're able to discover the API endpoints rather than have to know them ahead of time. Before I move on briefly, if you're doing JSON, you have to come up with a way of doing links. If you're using XML, it's not a problem. But in JSON, you need to standardize on a mechanism. We chose HAL, which is short for the hypertext application language, which just provides this mechanism here, the specified things, which was This is how a query might now look. Change client to API gateway. So the API gateway for, say, the IOS application rather than the client itself will make an availability request that we showed on the previous page for licensed Mr. Self-Reject service. Now, the availability API will query its internal data store that's being populated by events, and it will know all the information about Mr. Selfridge, but it will only return which episodes are actually available, the identifiers, and links to all the other information. So the API gateway still has to make some additional requests, and there's no getting around that. We're reintroducing some of the complexity back into the API gateway. It might need to make a catalog request and things, but say it's an iOS, it's an iPhone. Maybe it doesn't need the catalog request because there isn't space to show it on that screen. Okay, and maybe the fact that it's licensed is good enough. Maybe it doesn't need to show how long it's licensed for. So there are opportunities to save some requests. And overall, we went for our most complex query from making over 1,000 requests to just over 100, which is much more manageable. So this was fantastic for us. To review, we'd identified a new and highly cohesive domain at ITV. And of course, as soon as we told the business about it, I said, yes, that was there all along. Why didn't you ask us about it soon? But nevertheless, it provided a language for us to communicate with them in the future about what availability meant. And also, as soon as we identified it and said we've got this API, they said, whoa, can we use it to do monitoring? Can we actually can we query and find out when something is licensed and scheduled but hasn't yet had the guidance information set correctly? Actually, yes, the API does that, so or can very nearly. So we're providing something that was extensible but still very narrowly constrained, and which is good because it meant it wasn't going to get more complex even as it got more powerful. We decoupled our domain services from our domain aggregator again, which is great because now we can make changes in our domain services without having those bubble out necessarily. But we had pushed some of that duplicated logic back into the API gateway. 45 minutes I've got time to go on, didn't we? Yeah. Great. It was also a challenge for testing for us. I don't know if anyone has done any consumer contract testing. We'd like to, but we're not. We're struggling to see how we can make it work in this scenario. It deserves an hour in itself just to ruminate on, really. So I'll just leave it at that. But before I finish, because we've gone here, because we've done this Hatios APIs with our microservices, we also actually had a chance to learn a lot about versioning along the way. So I wanted to take 5 minutes just to touch on that really briefly, because it's really interesting. Here's how we did versioning when we started out, which, as everyone I'm sure knows, is wrong. We stuck with v1 in a URL. And there's really sound academic reasons for not doing it this way. Everyone knows that a resource should only have one location on the internet, and it should need to be updated just because the way that you're presenting it has changed. Everyone everyone knows that, yeah, everyone does this, and we do it too. Because despite there being an academic reason for not doing it, it's only when you actually encounter practical reasons for not doing it that you learn from your mistakes. And that's what we discovered. Because here's the availability API that also is version, and that links to the version of the catalog API, and that all works. But things will get interesting when you actually create a new version of the catalog API, because then you have an interesting choice to make. Either you update the version in your availability API, so that people can use the new catalog API, or discover it, I should say. And if you don't do that, then what's the point of updating the catalog API, because no one's going to find out about it. And if you do that, that actually changes, really, what this API does, because you're linking to another API that does something completely different. Which means you also have to update the version of this API. Which actually means that all that coupling that we just talked about taking out of our aggregation service, once you introduce versioning in this fashion, you put back into your APIs. It's like, wow, a wake-up moment, you can't do that. It creates this ripple effect again. So we needed to come up with another way of doing versioning. It's as simple as that. It was good. There's a couple of different ways of doing it. You could not version your APIs at all, which we're not smart enough to do at ITV, so put that aside. You can version the host header, which means instead of versioning each individual microservice, you version your entire API state, which again, why would you do that? That creates a monolith out of your APIs. So to eliminate that, you can do a couple of things. You can build custom version headering, so from API version 1. A version request parameter, so something on the end of the URL, but you don't actually include it in the link. You rely on people to put it there. Or you can include a version content type header, and then you can do content negotiation. What all of these different things have in common is that they take the versioning and they put it out of bounds. So it's no longer something that you do as part of the linking process. It's something that you discover via an alternate mechanism. We don't actually have a mechanism for doing that, but it makes it a separate problem, which is helpful. Whichever one of those you use, you end up with the same problem. I mean, I happen to like content negotiation, but there are challenges involved with doing it. Primarily, lots of frameworks and libraries and even routers struggle with really weird content types. But whichever one of these you use, you've got a problem as soon as someone doesn't send the version. Because you've got a choice at that point. Do you not work, which is really developer unfriendly, or do you give them the latest version of your API? If you give them the latest version of your API, what do you do when you update the API? You give them a new version, but that's going to break things for them. And lots of people won't realize they have to send a version, so lots of people will have broken API experience. So neither of those are very good solutions. So the final thing that we discovered as we were sort of thinking about how we do versioning and wanting to make it a really great developer experience for people working with our APIs was to think about how we solve that. And we did that because we were using content negotiation, thinking about what that actually meant. Here's the accept header that your average web browser is going to send when you just play around with an API for the first time by typing the URL into your browser. It's going to say, I want HTML on a web browser, but I'll take whatever you've got. And all we did was say, okay, if you want HTML, we could send you our custom JSON with a special content type, but actually no, let's give you HTML. So our response is actually this. It's got our JSON payload in it, but we've wrapped it in HTML, made it look pretty, and essentially unusable, so that we force people to think about, while they're discovering the API and liking it, how they're actually going to, which versions they're actually going to use in their own development. So we say what version they'll need to set. They want the machine-readable version, but we provide a nice human-readable version in the meantime. And these links actually work, which is fantastic, because that actually makes people click around the entire APIs and really get to know things. It reduces the amount of documentation you have to provide. This is interesting to compare with something called Swagger, and I don't know if anyone's played around with that. It's a great tool as well. That allows you to provide description of how your APIs work, and then in a special Swagger browser, you can plug in things into fields and generate API requests and responses. But what Swagger won't do, that we can actually do with this, which is really interesting, is Swagger won't give you the ability to take the response of one API and plug it into another API. You essentially have to do that yourself. because we can actually generate the links, we can do something like, in our APIs, for example, we provide different content depending on what region you're in. So once you've provided the region in one API call, all other API calls you make will have the links pre-populated with that information. And that can make it really much more powerful if we're browsing around. And I'm just surprised that we're not seeing more things like this around. I wanted to share it because it's been so much fun for us having this tool. Seems simple in retrospect. Okay, so thank you. Before I wrap up completely, I just wanted to say that these have been really useful discoveries for us within the context of our own project. No one should go away from this and say, I just saw this talk where this team did this particular way of developing microservices, therefore we must do it. Given the situation we were in 2 years ago, given the constraints that we had and the challenges that we faced, I hope that people might agree that this was one good solution that we could come to. What I'd like people to take away is how we learned and how we evolved and how we found out about our domain and how we grew, because that was really interesting for us. And really what we were doing is letting the system design during development. We weren't thinking about what microservices we need up front. We discovered them as we went. And we wouldn't have predicted some of the microservices that we ended up with. And but we also learned other things. We learned to take a lot of the concepts that we already got, these great things that we learned as developers about application architecture, and promote them to microservices architecture. Because a lot of what I've been talking about with cohesion and coupling, we're used to doing in modules and classes, but work just as well when thinking about microservices. And that's been really powerful for us. Obviously, the talk itself was framed around how do you compose microservices together. And here was one way and one situation that we dealt with that. I hope that we're going to get more talks around this subject, because I think it's really interesting to talk about how you put microservices together. And it'd be great if we could have conversations around that and more talks around this subject. And finally, we also learned to mix our architectural styles. We talk a lot about microservices giving us the freedom to develop things in different languages, so you can do it in Go, you can do it in Scala, you can do it in Node.js, whichever sort of language you want. We talk less about changing the way we do microservice development within an actual architecture. So you can develop event-based systems, HTTP-based systems, eventually consistent systems, all within one architecture, using the right data store for the right job is really powerful. And microservices aren't cheap, so it's great to get these things out of it, and you can forget to if you're not careful. And finally, watch out for the monolith, because it can come back. We were replacing a monolith, and we very nearly ended up with another monolith. And I think it's important for us all, whenever we're doing microservices, to remember that the original team that built the monolith that we were replacing didn't set out to build that monolith. They set out with the best of intentions and ended up with a monolith. Just because we're building microservices doesn't mean we won't end up with a monolith again. And we very nearly did. And it's been very educational for us to learn from that.
Okay, just time for a few short, quick questions.
Yes. Question? Yes. So I see you make a lot of calls. The client makes a lot of calls depending on the server response. So how do you manage authorization?
Authorization?
Yes, because there's a single point in the monolith way, but here there's a lot. It's like the channel is more wide for the IPA. I don't know how to manage.
I think we're a small team, and we haven't had the advantage that the awareness team have had of being able to develop a platform beneath our microservices. So we bypassed that question a lot to start out with. Once you're into our network, you can essentially make any API call you want, and we're not regulating those API calls. We're starting to provide those API calls, make those API calls available to other teams, but also external partners who are on other networks. And we're doing that on a case-by-case basis at the moment with API tokens. So I wouldn't say it's ideal. But with it, once you're essentially, particularly for the gateway, because we do provide a public API for the gateway.
anyone can use that. And once you're in there, it can make any call it wants to. We're also lucky that I've been talking about a read-only API essentially. So you can't mutate any of this data using these APIs that we develop because underlying systems are still very monolithic and problematic, and so you've got all sorts of nasty Visual Basic applications for actually verifying the data.
Any more questions? I have a quick question. You said you guys weren't smart enough not to version, which I don't necessarily believe, but did you consider at any point that it might be better to avoid versioning than go down the path you went?
Yeah, I mean, we definitely talked about it. I think for most situations as well, we don't increase the version number because we're just adding fields. But every so often you want to make a breaking change. And we've worked with vendors who also provide REST APIs, and some of them don't provide versions. And every so often they break their API, frankly. Even though they say we don't need to version, but then they go and break the API anyway. So, yeah. Sorry, no. So you had a question first.
You said it's possible to mix languages. Do you actually do that in your services, or is it all consistent?
We're entirely Scala. We have another team developing microservices, which has a mixture of Grails and Scala because they started out doing that. I think yes, we've also got some teams who are developing in Java, but it's I would say because we're a single team, it's natural that we're fairly consistent. The important thing that the operational members, so the DevOps members of our team, emphasize is that providing a binary and consistent way of starting and stopping things and configuring service are key things when developing microservice. Matters less what the language underneath is. So we focused on those as the things that should be consistent across languages. So a consistent configuration format, consistent start-stop, theming, semantics.
You guys, last question?
Yeah, I had a question on your consumer. So is the only consumer of this API service the sort of UI you showed us before? And who developed that?
So we developed that in as part of a single team because we were a sort of pathfinder or proof of concept for microservices within the company. We wanted to be working very closely with the first team to consume our APIs, and we're part of the team in fact. So we had some JavaScript developers that we were working with to be talking about the data, the APIs, and how that should work. And so them putting their application live was also the first time our APIs went live. So it was a bigger deal for us as for them. Now we're spreading the use of that API around to other teams. We're starting to sort of split up the original developers, and we're starting to think about how we pivot. Essentially, how do you go from a vertical team that can develop a feature at every level of your architecture to teams that can work on the UI and work on the stability of the underlying services, but perhaps at different velocities. I'm not doing all the answers to that easy, but that's where we are.
All right, thank you very much.